A warm welcome. This is Electric Energy Generation, Utilization and Conservation course, lecture 1.4, focusing on lighting. There are three methods for calculating the lighting effect. One is watts per square meter method, second one is lumen or light flux method, and third one is the point to point method. The first one is watts per square meter method. Watts is nothing but the power per square meter. Square meter represents the area. So how much amount of power is being applied or obtained from the square meter area. This method is more adaptive for rough calculation or checking. This is simply the thumb rule method for calculation. It consists of making an allowance desired on the assumption of an average figure of overall efficiency of the system. So how much amount of electricity, that is the power, how much power of electricity is being passed per square meter, and from which we can obtain how much amount of lighting. So this is what is a calculation made in watts method. While considering the lumen or light flux method, we have to calculate the total lumens received on the working plane. So this can be achieved with the certain factors like how many number of lamps are used, what is the wattage level of each lamp, and how is the efficiency of each lamp represented in terms of lumens per watt, and what is the coefficient of utilization, and also it is the depreciation factor is also considered. Either the depreciation factor or the maintenance factor can be considered. This method is applicable to those cases where the source are in a condition so as to produce an approximate uniform illumination over the working plane. Normally, this can be this type of method will be used for calculating the illumination level of working place. So, working place in the sense or studying place where the illumination level has to be uniform. Only then the eyesight will be proper, and then the work will be it will be encouraging the work activity. First, the total lumens received. How, number of lamps we can count, wattage of each lamp will be knowing about it, and now we should know about the total lumens received. How you are calculating? It is defined as the ratio of lumens reaching the working plane to the total lumens given out by the lamp or the lamps. It is known as utilization factor or the coefficient of utilization, because the lamp will be providing certain illumination, but the normally it is a basic nature of the light to get scattered. So we have to observe how much amount of lumens are being focused on that particular working plane. This value varies from 0.25 to zero point 0.5, that is 25% to 50% for direct lighting schemes, and it may be zero point 0.1, that is 10% to 25% for indirect lighting schemes respectively. Maintenance factor, it is nothing but the ratio of ultimate maintained meter candles on the working plane to the initial meter candles. So we know the light impact or its efficiency at the initial stage. After few months or few years or few usage hours, how you are maintaining the candles so that the illumination level is better. Its value is more if the lamp fittings are cleaned regularly, say zero point 0.8. So this is what is that we are maintaining the lamp surroundings and lamp fittings. In such a case, if it is clean, the value is 80%, and it is less. If suppose it is less of that, as much dust is present, it may be of 60%. Next, let us consider the depreciation factor. This is mainly the inverse of the maintenance factor and is defined as the ratio of initial meter candles to the ultimate maintained meter candles on the working plane. Its value is greater than unity. While considering point-to-point or inverse square law method, we can see the calculation is made by considering the illumination level, the area where the illumination is being made, and the luminous flux produced per lamp, the utilization factor, and the maintenance factor. So now here what is calculated is the number of fittings required. This method is applicable where the illumination at a point due to one or more sources of light is required. The candle power of the sources in that particular direction under consideration should be a known one. This method is not much used because it creates complications and cumbersome applications. It is employed in cases where flood lighting or yard lighting is used. This is how many number of fittings is required. This is the case.